upload this tar file, when you open it, you're going to see one directory called Autodock4 and another one called AutodockVina, as well as a Word file. And the Word file included the links to all the applications I used. You don't have to download B or C because I already put them in their respective folders, and it'll just be easier that way later on. You will have to download A as well as D if you don't have it already, because that A won't work without it. So when you download A, you're gonna get all these applications here. We want to open up Autodock Tools. Oh, sometimes you gotta hit this remind me later button so I can open. So what we want to do first is set our directory. We're mostly going to be working in this Autodock4 folder, so I think I had set it to that earlier. Yep. So I'm going to set it to that. That way it will work fast. So the first thing we want to do is open up the macro molecule, so the receptor. And in this case, it's 1FK. So this in the later steps was giving me a lot of problems because it was saying that there was a hydrogen and I think it was arginine residue 1 that didn't have that wasn't bonded to anything. I think I can get the error message to pop up. It's this one. So it said found non-bonded atoms in this PDB, so it mentions this hydrogen and this arginine 1. Anyways, to avoid those errors, I deleted all the hydrogens that already came with this PDB, and I just let Autodock add it the way it wants. Just like that. When you do this, you don't get the errors later on. It's helpful. Now, we want to upload the ligand. So, input, open. We're looking for a PDB file. In this case, we're going to use PH4045. And I chose this one because it was giving me the most problems. And you'll see what they are. So I don't know if you saw that, but there's this error message that pops up. Now, when you go and look at it, let's hide this one. I think if you click R, you get a better picture. Now you see there's this carbon atom that was never bonded to this carbon atom here, which is why I included this picture so you could see it. You can see it better. You see there's this, I don't know, this is a triple bond. This carbon never bonded together. Now I don't know why, and I didn't know how to fix it, but I just restarted with the Mol2 file that was already in the Google Drive, and I converted it to a PDB. The new PDB, I'll show you how I did that right now. Let's just do it real quick because I gotta do it anyways. So I used that link. Oh, I don't know what was that. I use this link right here. This web service that converts files together. So we could choose Mol2, a Mol2 file, which is why I included it here. And we can say we want to output a PDB file. Then we hit go convert, and we can download the result. Now it's in our download, so I'm going to change the name so it doesn't get confusing later. We can call it new BH45. I'm going to copy it. We're going to put it in the folder I'm working in. This is the Autodock. Okay, now it's in there. We don't need this anymore. We can go ahead and delete this one. And we can upload it again. So we go ligand, input, open. We look for this PDB, so it's this one. to see that now. I know the bond looks yellow now, but it will look green after. I don't know why it looks like that. But now I can actually see this carbon to carbon bond. Okay, you see, there it is. So that's better. That solves that problem, because before, if you try to dock it, it didn't work at all. So we can go ahead now and start working on the parameter file for AutoGrid. Unhide this one. Sometimes it gives you this weird picture. If you just click N, it'll go away. So there we go. So now we want to select our macromolecule, which is 1FKN. We can also set up the grid box. Oh yeah, I forgot. That's why I'm going to take this. So you're going to hit OK. It's going to ask you to save. So this is one of the files you're going to need for later on. This is the PDBQT file for the 1FKN. And this one always comes up. Next, we can choose. Oh, well, before we do that, since we already saved that PDBQT, we can also save the PDBQT for the ligand. And it's labeled right here. Save. So now we got those two files. We can check desktop. Autodock4. So these two PDBQT saved. We can also, well, after that we can set up the grid box now. Now, I know you mentioned blind docking that day, so I figured I'd just include the entire thing to be the search space. And we're going to make this a little bigger too. I think 126 is the maximum. So this covers the whole thing. And these X, Y, and Z I didn't touch. Alright, so then we can hit File, close saving current. That takes care of that. Now we gotta set up the map types. And this one we just gotta choose a ligand. So, which is the new pH 45. Next, we'll just pick grid, output, and we'll save this GPF, which we're going to use for the AutoGrid program. We could just name it 1FKN pH 45 .gpf. Now let's just check if that file was created. Yeah, it's right here. Next, we can go ahead and run AutoGrid. Here we'll just have to choose where AutoGrid is. So since it's already here, we can choose it right there. Open, and parameter name, we can just choose this one. It's the one we just made, and everything else will generate by itself. Then we hit launch, and we're going to get this process screen. We're just going to wait till it goes away. And then it's making a bunch of files. So we'll just wait till that goes away. Okay, so it's finished, and you'll see that this is the last file that was generated. It's .glg. So after that, we can go ahead and set up the stuff we need for the Autodock4 program. So first, we want to, same thing, go to macromolecule and then set rigid file name. So we want to set 1fkn. Afterwards, we're going to set the ligand. Choose our ligand. And here we can leave everything as is. Hit accept. Then we can set up our search parameters. We're going to use the genetic algorithm. Here we can decide how long we want it to run. So we're going to run something short. And let's say we want 25 runs. Hit accept. And afterwards, by ducking, and that finishes everything there. We can go then try and get an output. I'm going to choose the first one. And we can go ahead and name it, same as pH45 .dpf. Save, and then we can go ahead and run Autodock. Now we want to look for the Autodock4 program. It's in the folder right here. And then we can look up for the DPF file that we just made. So after that, we can go ahead and click launch. Again, we're going to get this little box. And we're going to wait till the little box goes away. It means everything is done. In the meantime, we can actually do AutodockVina, because for AutodockVina, all we need is the PDBQT of the receptor and the PDBQT of the ligand. So this was this. We can copy this one. Well, we can copy both of them now. So this is, oh no, that's not it. So this is one of them. Where is the, oh, here it is. Those are the two PDBQTs that we generated earlier. Go ahead and copy those. And we can paste them in here. What you will need for this is also this file, which I'll show you right now what it has. I think if I drag this here, I can actually see what it has. Yeah. So here is almost the same thing what we used for the grid box. So if we look what we used, we can include the same numbers. So 126, 126. This is the file that's going to be outputted, and this is the number of runs. The same thing like the GA runs that I just said right now. Okay, and we also got to put the receptor and the ligand, obviously. Oh, but in this case, did I name it PH45 or did I name it? I think I named it. Oh, I named it new PH45. So I gotta switch that. New PH. It's gotta be exactly like it was written. Yep, so we can go ahead and save that. Now to run that, oh, I think the other one finished because the box went away. Okay, so that's good. I'll show the output file after. So what we can do is we can go and open up the terminal, and we're gonna go to this directory that we were at. So I think I named it. What did I name it? Oh, Autodock tutorial, and then Autodock So we want to call this Vina program, and the code to do is just like this. Figure.txt. That's all you need to do. And we can go ahead and run it. And you'll see here, then it will say setting up. Now it's going to take a little time. Meanwhile, we can see what was outputted before. Autodock4. So all of this was outputted. The most important file is going to be the .dog file. It's generated here. So that's right here. So in the meantime, we can actually, I don't know how to analyze all this stuff yet, but I know how to open it at least. Analyze docking is open. Use this .dog. And there's a play button here. Let me hide all these. So this is one of the confirmations. I think if I go to, what was it again? I think it was confirmations. Oh yeah, play rank by energy. No, but it always hides it for some reason. So yeah, here we see all of the confirmations that were generated. So then afterwards, this just finished, so we can see what was made. And so we're going to use this file right here to upload it into Autodock. So it's right here, 1fkn. Alright. We pick sample molecule. We can go ahead and hide this one now. Oh, this is going to upload everything. Oh, I'm sorry. What am I doing? I'm confused. I was like, what? This is not it. I was in the wrong folder. It's Autodock tutorial, AutodockVina. Page 40, yeah, this one. I was like, there's something wrong here. So that's this one. There we go, that makes more sense. So then here, if you hit left and right, we can see the energies. I think, how many were generated? I think it told us here. Yeah, there were 20 generated. So the first one is the best one, 5.8. Yeah. And then you can see the rest. Yeah, they're scattered all over the place, but they're somewhere. So yeah, that's how I docked both of them.